So now we're going to switch to a GPU particle system. So we're going to create a new base. And we're going to call it 2D particles So the first thing we want to learn is, so this time we're going to use a texture only to store data. So we're going to store point position in pixels. So to start with, we're not going to do any animation. We're just going to do like static particles. So I'm going to put down a noise stop. And I'm going to set it to random. And I'm going to uncheck monochrome. And so now we're going to say we have 256 times 256. Maybe I'll just make it round. I'm just going to do 200 by 200. So we have 40,000 pixels. And we're going to say each one has RGB values, and each one represents a point in space. So for this, now we want to use 16-bit or even 32-bit float, because the point position can be positive or negative. We don't want them all to be, and we need more precision. We don't want them all to be like between 0 and 1. And on the noise, we are also going to put the amplitude to 1 and the offset to 0. And so now if I guess I can just use, yeah, the thing with the, sorry?
Offset 0?
Yeah.
Okay.
And so what it does is now we have a collection of values. So you can see red and grid, they're all like between -1 and 1. By default, when it's 0.5 and 0.5, everything is going to be between 0 and 1. So yeah, just I like things to be kind of centered on the origin. So just going to do this. Now I'm going to create a null top. And I'm going to say it's called particles positions. So now what we want is we want to create one point for each pixel. And we want to look up the RGB value and move the point at that position. Yeah. So we're going to create a geometry comp. And if we want to render points, which single points, so no polygons, no quads, which are the lightest things to render, the easiest way to do it is to put down an add sub. And you're going to check the first line. So it's going to give you exactly 1 point. So it's a 1 point, 0 primitive, 0 vertices. Oh, bless you. And now we need to convert that to a special type of primitive, which is called point sprite. And how we do that is we use a sub2. Bless you. That's a dat. And I'm going to point it to add 1. No, maybe there's a simpler way now. Just let me convert. Oh yeah, no, that doesn't work. Okay, so yeah, let's do this. And now I'm gonna do a dat2 in the sub. So it's a bit quirky. I wish they would just add a checkbox on the add, so you could like say I want to create a point sprite, but.
So what is that? What is the add?
So the add, it just creates a simple point at the coordinates I'd give him. I could like.
So why is it called an add? Oh, so it's just
'Cause-
adding a.
Well, but also it does other things. You can also use it to connect points together.
Okay.
It's another function. Yeah, we don't need to learn about it now. And then so we're going to put down the dat2, and we're going to say build particle system using all points. And now what we have is we have 1 point, 1 primitive, 1 vertex, 1 particle system with 1 particle. And that's what you need to be able to render point sprites using a shader.
Do we need to switch particle type to render as point sprite or rendering as line?
Yeah, you need to do, I think you need to do, render as point sprite. Good call. And you want to click the render and display flag.
Tell me you have a bad path when I try to. Points to what is it? The dash view of the point.
So you want to make sure you point the sub2 in the points. You have the kind of little arrows that like, so the sub2 points to the add one, and the dat2 points to the sub2 one, and you change the type to.
Is there a reason why you prefer to use base columns over
Containers? I think, so containers, you use them to build user interfaces. So if I don't need widgets or anything, and it's just for like tidying my networks, then base make more sense. Because otherwise, if you like build an interface and you have some containers deep down, maybe they're gonna show up if you have like buttons and stuff like that. So also one thing, if you ever need to convert between the two, you can always right-click and do change comp type, and then you can like turn it into a container.
So a container. Did you just explain the difference between the base and the container?
Yeah. So the base is just for organization purpose, but you can't build user interface with it.
Right. Container you can.
Container you can. So I'm gonna change it back to a base. Yeah. Now the next step is let's create a Fong, but we're gonna turn off the diffuse, turn off the specular, and turn on the constant. And then I'm gonna output it to a shader.
When you say turn on constant, just all one.
Yeah. So what you want is when you click on output, you want not lighting.
Oh, I should already say that.
Yeah, I'm doing that since some people have a older build, because otherwise I could just start from the GLSL mat that comes with like a super lightweight. I mean, this comes with like a few useful things, so.
So you just created a Fong and then output the shader.
Yeah, but I put the diffuse to 0, the specular to 0, and the constant to 1. So now I'm going to assign this new fung, and I'm going to delete or just put this one away. Just for the sake of simplifying things a bit, I'm gonna delete all the things about picking. So I'm gonna delete this block and this block. So it's like a little, and I can also delete all these which are not used here. So yeah, I have there's a block which is related to whether you want to use kind of 3D picking. So we don't need to use it. So I deleted the uniforms at the top. We're making the change to the vertex shader, not the pixel shader, the vertex shader. Okay, so now what we want to do is we're going to turn on instancing on the GO1. For the instance count, we're going to set it to manual. And so what we want is 40,000, which is 200 by 200. So one way to, a quick way to just match the texture, I can use OP particle positions dot width as an expression times height, where it's like yeah, this is, if you can't read it, this is what I'm typing in the number. Oh, I want to type that in the number of instances. So I set it to manual, and num instance is. So that's one thing.
So you did that instead of using the instance chop that stuff?
Yeah, because we don't have any chop.
Chop,
We just have a texture. So yeah, so you need to specify manual. And now what we want is we want each instance to look at a specific pixel in this texture. So let's say we had only 25 particles. So particle 8, it's going to be this pixel. And it's going to be the first column and the second row. So we're going to use a new, this new function called Texel fetch. And Texel fetch, instead of taking normalized 0 to 1 texture coordinates, it's going to take pixel coordinates. So what we want to do is Texel fetch and give it 4 and 2. And how do we find 4 and 2 from 8? The row is going to be 8 divided by the width, which is 5. And then the column is going to be 8 modulo the width, which is also 5. So the modulo operator is when you do a division, it's the entire rest. So it's like when you do 8 modulo 5.
Oh, it's the remainder.
Yeah, the remainder, exactly.
Okay.
0, 1, 2, 3, 4, 5, 6, 7, 8. So 8 divided by 5, it's only 1, and then you have 3 as the remainder. So that's this number. And 8 divided by 5, the entire, so it's only 1 if you dot something. So this number. Yeah. And so that's how you can find a coordinate. So we can do it with another one. If I do 8, 9, 9, 10, so 11. So 11 divided by 5, we're going to have 2 and something. So that's the, oh yeah, I'm doing the row. So, sorry, I keep getting confused. So this is for the row, so it's going to be 2. So that's correct. And for the column, it's going to be modulo 5, and that's going to be 1, and that is correct as well.
So that's how you find them.
So that's how, using the instance number, you find the XY coordinates in your texture. Yeah. So, so we're gonna go back to our vertex shader. We're gonna edit it. And so Texel fetch, it takes only integer coordinates because it's pixel coordinates. So you can't give him like point something floats. So we're gonna say integer row. So it's gonna be td instance id, which is our instance number. And I said the row is the yeah, the row is the modulo operator.
No.
No?
The top one, the row is 8 divided by 5.
Yeah, exactly. So the column is, yeah, so the row. Yeah, I guess it depends if, yeah, okay, yeah, it's the row.
So that would be width, right? You're going to divide by the width? Is that what, or
yeah.
Yeah.
Yeah, divided by the width of my texture, which I need to introduce as a uniform, because I think, yeah, maybe I could get it like, I think there's a function to get the size from a sampler, but let's just do, yeah, let's just do here width, and we're gonna divide this by u width.
Is that a...
And we need to convert, if you convert to int like this, it's gonna only keep the integer part. It's gonna just discard the fractional part.
So, question for you, the uniform u width, you didn't...
Oh yeah, I
Is it
completely,
supposed to be a float?
this is gonna be an int, because it's also gonna be something in pixel. Yep, yeah. And the column, it's gonna be integer tid instance ID. And this time it's going to be modulo width. So if you save that, it should compile
What is
well.
the TD instance ID? That's
It's the
The actual
instance number.
for what?
It's the instance number.
point of the
Okay.
So we're doing 40,000, and so it's going to go from 0 to 39,999.
Gotcha.
And yeah, and that's how we know which instance we're dealing with. Because otherwise, everything is the same. Yeah. And the other thing we need to create is the sampler, which has the particle position. So we're gonna do uniform sampler to D. So this we never had to do it because Touch was doing it for us. But basically, the STD to D inputs in the background, they're like declared using a uniform sampler to D. And we're gonna say S positions. And now we're gonna say so vector 3 new position is equal to Texel fetch S position, and then so instead of the vec2, it's an I vec2, which is integer vectors, and you can give it so it's going to be col and row for the x and y coordinates. And this also needs another argument, which is the level of detail, which has to do with mipmap. All you need to do is you just put 0. And then you save that. And so same as before, we get an error because we want just the first 3 values. So we're going to do time dot xyz. And so now a new position should point to the value in each hole in each pixel for each particle. And so we're just gonna replace the we're gonna get rid of the. I mean, we can just apply a new position in the TDD form. So
Sampler 2D, what is that?
it's a texture. Yeah.
Data is
What?
what kind of data type?
They can be like many type. It just wants like a top, basically.
And IVEC 2?
So it's a vector 2,
Yeah.
but integer. So both components, instead of being floats, they have to be integers. Yeah. Yeah. When you do Python and the variable don't need to be typed, it seems silly. But like this, you need to wants to know integers, float. It wants to know all that.
How do you apply
Would it make a difference if it was? So what would happen if you just had a vec2?
It's gonna-
you put floats, but yeah, if you put it.
So if I put a vec2, it's gonna error because it's gonna say I cannot find a function Texel fetch sampler to the vec2 int because the function takes sampler to the ivec
So even
int.
if you put 1 in for column and 1 for row, it would still give you that.
Yeah, because
Okay,
it would
gotcha.
because it would.
It's the type.
But if you do this, then it's It's the constructor for IVEC,
Oh, you
which is
just
the same,
around.
similar. So.
So much cooler.
So now we need to connect the shader with the texture from TouchDesigner and give him the width uniform. So on the samplers one tab, we're gonna create a first one called S positions. And we're gonna point that to our top.
Oh, you put a box there.
And then in the vectors one, we're going to create a new one called U width. And that's going to be same as we used here. It's going to be the width of our texture. And now I think we should see something in the viewport, or if we were rendering things. But yeah, and so I haven't set up any camera render, so I'm just looking at the geometry viewport. And so you can see I get this cube of points. And so each point looks in the texture to get XYZ coordinate. Yep.
The width.
The width, I'm using again the width of the particle position texture.
Just for the X value, or for?
Just for the X value, because it's a float. We don't need the Y value.
Where did you? How are you viewing that with the geometry view?
So I'm gonna yep. So first I split the viewer in two panes. Here at the top. You can also do it here. You can also do split left-right on this little arrow. You can do that too. And then there is this little arrow, which allows you to choose what you want to see, and here you choose geometry viewer.
Can you show me the other vectors you have on the GL?
So the only one I added is U width, and the samplers as position, which is linked to the particles position top. Maybe I'll just gonna.
Mess something up.
Yeah, I'm not getting that.
You're not getting the point.
No.
Okay, you're on the Mac. You're getting the point, so that's good. Yeah, if you put a noise, you're gonna have something more structured. Yeah.
So on the width here.
Oh, so it's only the width. You don't have to multiply by the height.
Okay. That's probably what's going on.
Do you have a camera?
Because yeah, in our math to find the coordinates, we're just using the width of the texture.
Make the viewer active. And
Yeah.
it's moving.
Yeah, you need to select something else at the GO1, because when you select it, it's going to apply a default shader and disappear. So,
Can you get your code up?
yep.
Can't seem to get it. No,
The what?
the vertex.
Oh, yeah.
Do you think
Can you unpack what this Texel fetch is doing? Like
Yeah, so it's pretty close from texture, and with a few differences. So one of the differences is instead of taking UV coordinates, which are normalized between 0 and 1, it takes pixel coordinates. The other thing is that texture, by default, is going to interpolate. So if you, so you have, so with texture, if the coordinate you give like kind of falls here, it's gonna kind of mix the two pixels to like give you a blend. But Texel doesn't interpolate. Texel is always going to give you just the value. So that's another thing. Another thing is the thing the repeat mode for the texture. So that only works with texture and not Texel fetch. So a Texel fetch is kind of nice when you're dealing with data and not pretty pixel. Because for this we never want to kind of mix two pixels, because each pixel is like an entity, like this XYZ coordinate. And we want to be sure we like just eat this pixel and like not any neighbors. So yeah, so it's just a few differences.
Yeah, but regarding the first argument and the second argument, is the first one the XYZ, and the second one is the...
So this is something unrelated.
Yeah.
So this is the XY.
Oh, that's the XY.
Yeah. So this is the sampler, the texture. This is the XY. And the 0, so it's the level of detail. So we don't really need to know about it, but usually when you create textures, the driver is going to create a scaled-down version of the texture, which are called MIP maps. And they're used as a cheap way to do anti-aliasing for like things that are sampled far away from the camera. So anyway, this allows you to specify which level you want, and you always want the base level, which is 0. So for our purpose, this is always going to be 0, but you still need to include it. Yeah, it's to fully make sense. Like you need to know like a little more about textures, but I think that's good enough. Yeah. Why does it make a square?
Yeah.
So it makes a square because my texture, my random value texture, all the values are between -1 and 1.
Okay.
And
so the most extreme values will only be 1, which creates a square.
Yeah, because there are enough points to kind of fill the whole volume.
Cool.
Yep.
Question two.
Yeah, so quick to kind of emphasize that, if I go on my nose and I change the amplitude to 1.5, you can see now it's scaling, because now all the values go to 1.5, so it makes a bigger cube.
That's essentially what I was trying to get at, is how do you
Yeah.
scale this noise now, or this shape that you've made, and it's in the noise. Essentially all the controls for this would be in the noise.
Yeah, well, this only demonstrates how, when you have a texture and you treat the pixel as point position, how you render them.
Right.
It's the end goal is not to make it's cool to make a cube.
No,
yeah.
It's not at all cool. It's kind of boring.
Yeah, so if we wanted to do...
Would you have to do that in the pixel shader?
Yeah, you would need to, in the vertex shader, you would need to
Output.
assign, so the out vertex, you have this vec4 color that's already created for you. So you could sample the same texture or a different texture and assign the value in the color, and that would get passed And then you want to make sure you use the color inside the pixel shader.
Okay, so you would have to pass
Yeah.
the color from the
From-
vertex shader to the pixel shader, which is sampled initially from the vertex
Yep.
shader, and then you have to also pass it.
Just as a very quick, so you see color by default is this thing. So if I comment it and I say it's going to be vec4 new position 1. Ta-da. And the funny thing is, since the colors are positioned, now they're kind of sorted in space because they go from -1 to 1. But for example, just as if like I was doing, I'm gonna do something else. So what I could do vec4 td simplex noise new position and now what it does, it's sampling 3D noise based on the position of the particle. So if I can like scale it. So if I do 0.2, no, that's too little. But if I do 0.6, so now you're kind of visualizing like a 3D noise in space. Another thing, if you want to make the point bigger, there is a built-in uniform called GL point size. So if we do 2, each point is going to be 2 pixel by 2 pixel instead of 1 pixel by 1 pixel. And this is it's pixels and it doesn't scale with the perspective, so that's why when you zoom in and out, the points are the same size, so it's going to feel more or less.
What is it? It was point size with a capital S?
Capital P.
Capital P, capital S. Okay, so we're kind of running out of time. So I think so now if you wanted to kind of do a dynamic particle system, so I'm gonna demonstrate with something I had already created. So here what I'm doing, it's kind of the same. This one is just in 2 dimensions, because the easy thing with 2 dimensions is then you can use any texture as forces into your particles. And so using the optical flow component from the palette, I can like kind of, just from an animated texture, I can like derive forces. So the rendered grid components are like X and Y direction. So just the optical flow by itself, it's like a, an approximation compared. It just gives you like the direction on the edges. But if you kind of fit that in a fluid solver, then things kind of get a lot more interesting. So this is why I had in the files there is this stocks 2D fluid. And so I drop this here and kind of connect to my velocity. So I had to change a few things. So every frame I'm just going to override the velocity with the velocity of the fluid. And now I can like kind of boost it a little. Oops. And then I'm just gonna activate the, gonna get the point size to 1. So now it's like already like nicer because you get like all these ripples. And the nice thing is I can just kind of connect my webcam. Here I am. And I'm gonna plug this into the optical flow. And now you can see I can. So you need to maybe boost it. You need to boost it a little. But yeah, so that's like the kind of classic webcam-driven particle system. And then you can like do like color the particles based on their speed. You can also kind of emit particle in only in certain spots.
So I see you're using a feedback top in there to like.
Yeah,
like
so
constantly regenerating the or recalculating the position of the particles.
so how a typical particle system works is that each frame, it's going to use the position from the last frame and add it a velocity to move the point. So you need the feedback because every frame uses the result from the last frame. And so that's why you have this, this feedback loop.
So it's very similar to what we did in one of the earlier examples, right?
Yeah, yeah.
I have a question for you on that.
And that's like the raw vectors from the fluid, so you can
Oh,
kind of also mix that in, give some nice. And just very briefly, but so the
Just real quick, this one.
no, I was gonna say I mean the fluid, like you don't. The general idea is you have one quantity which is the velocity, and it's gonna move itself. So every frame you kind of sample one spot, and you kind of follow the velocity field and kind of move the velocity by itself. And then you have one step, it's that the velocity field has to be divergence free, which means basically that if you try to like make a force that grows this way, you're gonna have like swirls because it needs to like be positive and negative to kind of stay zero. And so this whole part is like, it's pretty, it's kind of computing these like different elements to render the velocity divergence free, and that's where you get the fluid source from. But yeah, yeah. So yeah, running a bit out of time, but then you can like do all kind of cool stuff. Just one last thing. So in the palette, if you go to Tools, you can find the particles GPU sample. And so it's like similar IDs. And another thing it does, it uses a geometry shader. So instead of points, it creates little quads and can animate them in space. And so that's done with the geometry shader. And the geometry shader is like a step between the vertex shader and the fragment shader. And you can create some geometry, but you can't create a lot of geometry. You can create tiny things, but it's not. You're not going to create 1 million points with the geometry shader. But you can do like a number of like interesting little things like for particles.
more for like creating geometry to then like instance or something like that?
Yeah. Yeah, one thing you can do also, if you have like a line, you can like turn it into a tube or a ribbon. You can like kind of build geometry around the line. You could do that in the geometry shader. I end up not using it that much because a lot of time I'm just gonna use an existing tube and deform it instead of creating it in the geometry shader, and that's gonna be faster.
Right.
So, yeah, thank you all for coming. I hope the pace was. It's hard because there's like kind of a lot of like basics to cover before you get to the more interesting things. Yeah, I don't know. Maybe next time I try to do like a 2 days thing, but I'm still happy how gives a lot of insights and like. Also for people who are more beginner with TouchDesigner, there's like plenty you can do, which is cool without diving into coding stuff. Also, so I don't want to yeah. But when you want to optimize things or like do more custom system, it's like it's nice.